Assalamu alaikum dear students. In previous video lecture we discussed about the increasing and decreasing functions, how derivatives are used to find whether to check whether the given function is increasing or a decreasing function. Today we are going to discuss the solved problems in which we use the derivative test to check the increasing and decreasing function. Now first problem, which is question number 3 of exercise second, is show that f of x equals to sine x is strictly increasing in interval 0 pi by 2 and strictly decreasing in interval pi by 2 and pi. Now we will use here the derivative test to check that this function, that is sine x, is strictly increasing in this interval while as it is decreasing in interval pi by 2 and pi. Now when f of x is sine x implies that its derivative, that is f dash of x, is cos of x. Now this cos of x, part A, which is interval 0 and pi by 2, means first interval in this first quadrant, and we know that in first quadrant each and every trigonometric function is positive, which implies that in particular this cos x is positive. Hence a derivative, that is f dash of x equals to cos x, is greater than 0 for all x belongs to 0 pi by 2, which implies that f of x equals to sine x is strictly increasing in this interval 0 and pi by 2, because we have proved this theorem which states that when f dash of x is greater than 0, this means that f is strictly increasing, while as if f dash of x is less than 0 implies that f is strictly decreasing at in that interval. Now we have to check it is decreasing in this interval. Now f of x is sine x implies that f dash of x is cos x. Now this interval, that is pi by 2 and pi, open interval pi by 2 and pi, is second quadrant. In second quadrant, this only sine and cosec are positive, implies that rest 4 trigonometric functions are negative. Hence in particular f dash of x equals to cos x is negative, which implies that f dash of x less than 0 implies that f is strictly decreasing in this interval pi by 2 and pi. Now part number C of this question show that this f of x is sine x is neither increasing nor decreasing in interval 0 and pi by 2. Now this 0 and pi by 2 contains two intervals, that is 0 and pi by 2 and pi by 2 and pi. This means that in first quadrant it is increasing, in second quadrant it is decreasing. But if we consider the general these two quadrants, that is interval 0 and pi, this means that function is neither increasing nor decreasing in this interval 0 and pi by 2, because in this interval the graph of the function looks like this. Here this means it is increasing, while as in this interval it is decreasing. Now find the interval in which this function 2x square minus 3x is strictly increasing and strictly decreasing. We have to find now the interval where this function is increasing and decreasing. Now here the rule for this to find the interval is, here given function is f of x equals to 2x square minus 3x. Now its derivative, that is f dash of x, is 4x minus 3. Now when f dash of x is 0, which implies that 4x minus 3 is 0, or x equals to 3 by 4, which implies that x equals to 3 by 4, at this point derivative is 0. Now this point, this where the derivative is 0, this is called as the stationary point. Now informally we can say that at stationary point the function is neither increasing nor decreasing. So this means that this point is the stationary point, or sometimes it is called as the critical point. At this point where the derivative is 0, the function is neither increasing nor decreasing. Now the second application of this, where the derivative is 0, means at this point the tangent is parallel to this x-axis. But here at stationary point, by considering the increasing and decreasing concept, we say that at this point the function is neither increasing nor decreasing. That is why this is called as the stationary point. Now this point, that is 3 pi by 4, this function has only one stationary point, that is 3 pi by 4, and this stationary point divides the interval, because the domain of this is R, divides the interval into two disjoint intervals, that is minus infinity to 3 pi by 4 and from 3 pi by 4 to infinity. So these are disjoint. Sometimes this disjoint division means partition. Partition means when this when the union of the given disjoint sets is given R. So simply we say that this R divides it into intervals minus this 3 pi by 4 divides this R into intervals minus 3 pi by 4 to 3 pi by 4 to infinity. Now we will check in your derivative in these two intervals, the sign of the derivative in these two intervals. Now f dash of x is 4x minus 3, which implies that in interval minus infinity 3 pi by 4 this is negative, which implies that when it is negative implies that minus infinity 3 pi by 4 is strictly decreasing function. Now similarly in 3 pi by 4 to infinity, for all x this f dash of x is positive, you can check it, which implies that when derivative is positive implies that f is strictly increasing in interval 3 pi by 4 to infinity. Hence in this way we find the intervals where the function is increasing and where the function is strictly decreasing. Now similarly f of x equals to 2x cube minus 3x square minus 36x plus 7. We have to check, or we have to determine the intervals where the function is strictly increasing and where the function is strictly decreasing. Now f dash of x is 6x square minus 6x minus 36. Now at stationary points, means for stationary points derivative is 0, means that 6x minus 6x square minus 6x minus 36 is 0, or by quadratic rule x equals to 3 and x equals to minus 2. So this means that here we have two stationary points. So these two stationary points divides the R into three disjoint intervals. One is minus infinity 2, minus 2, minus 2, 3, and 3 to infinity. Now we will check the sign of derivative in these three intervals. Now here derivative is 6x square minus 6x minus 36. Now in interval minus infinity minus 2 and 3 infinity, this derivative, that is f dash of x, which is defined 6x minus 6x minus 36, derivative is positive, means that these two intervals, in these two intervals this function is strictly increasing, while as in second interval, that is minus 2 3, the derivative is negative, implies that the given function, that is f of x, is strictly decreasing in this very interval. So this is the procedure to find the intervals in which the function is strictly increasing or in which the function is strictly decreasing function. To check or to find the intervals, we simply find the critical points or the points of this stationary points. Now second question number 7 of this is y equals to log of 1 plus x minus 2x upon 2 plus x. X greater than minus 1 is increasing throughout its domain. Now its domain is, because log of x, if we consider log of x, domain of log x is greater than 0, which implies that for this function, this 1 plus log of 1 plus x, its domain is 1 plus log x should be greater than 0, which implies that x should be greater than 1, implies that this interval minus 1 to infinity is the domain for this function. We have to check that this function is increasing throughout this domain. Now here we will find its the derivative. Now derivative by usual methods is given by dy by dx equals to x square upon 2 plus x square, because here we differentiate first 1 plus x and then differentiate this 2x upon 2 plus x by using this quotient rule of differentiation. After simplification, you simply get dy by dx is x square upon 2 plus x square. Now for stationary points, this derivative is 0, implies that x square upon 2 plus x square equals to 0, which implies that x equals to 0. So only we have one stationary point that repeats, that is x equals to 0. So this point, this stationary point, is divides the domain into two disjoint intervals. One is -1 infinity, second one is because its domain is -1 infinity, which implies that this 0 divides it into two intervals, that is -1 0 and 0 infinity intervals. Now when x belongs to -1 0, means x is negative. When x is negative, so this means that its square is positive. Hence 2 plus x ka whole square is positive. So quotient of two positives is positive, which implies that x square upon 2 plus x ka whole square is positive, which implies that dy by dx is greater than 0. Similarly, in interval this 0 infinity, x is positive, x square is positive, 2 plus x square is positive, implies that their quotient is positive, hence dy by dx is positive. So this means that in both intervals, this dy by dx is positive, which implies that it is increasing function throughout its domain, because because this derivative is positive at each and every point, that is -1 0 and 0 infinity. So inshallah, in tomorrow's video lecture we will solve a few more problems to find or to check the whether the function is increasing or decreasing. So thank you.